Okay, welcome to another Adventures in Statistics Land. So today in class, later today in class, I'm going to show you how to do a t-calculation or how to calculate a t-score for a probability distribution or a t-value, however you want to call it. So I've set up two examples here, one in which I'm going to look at increasing the confidence level and what that's going to do while keeping the sample size the same. And then keeping the confidence level the same and then changing the sample size and seeing what that happens with our t. So I've kind of got this set up already and ready to go. We're going to go over to graph, choose probability distribution plot. I'm going to choose probability view and I'm going to select OK. And I'm setting this up for a t, and you have to be careful. Although my sample size may be 30, remember my degrees of freedom is one less than my sample size, so I got to change that to 29. And then I'm going to go into my shaded area. I want both tails to have my probability in them. And notice I have the tails I'm talking about. So confidence level makes up the inside of the distribution. So in here I want it to be 90%. In my tails I want it to have the leftover, or the 10%. Now you could do this as just a left or right tail and then have one of these tails be 5% each to make up for, the 10% that's left when you're doing only half of it. I'm going to do both of them together for fun. We're going to hit OK, and we get the t-score. So my t-score for A is 1.699, and it notes that half my area is 0.05, just like I said a minute ago, and my degrees of freedom is correct at 29. I'm going to do this again, so I'm going to select Graph, Probability Distribution Plot, Probability View, select OK. I'm still keeping my degrees of freedom the same, but I'm going to change my shaded area to 5%, since for B I'm looking at a 95% confidence interval, so my two tails will have the 5% in them. And we'll hit OK. And there's our plot. So I notice that my t is now 2.045. And I'm going to pull up that other graph if it'll let me, so you can quickly sort of compare these two, or maybe just compare their bottoms. Hold on, I'm going to put that one right there, and this one just below it. And then you can look at their tails and hopefully see that if you line them up, oh yeah, that one does have less area in it roughly than the other one. Let's do it again. One more time. All right. Una vez más. Here we go. So 99%, keeping my sample size the same, so my degrees of freedom is still 29, still the t-distribution. Shaded area, going in for the tails. Since it's 99, I'm now putting 1% in the tail. And then I'm going to hit OK, and it should give me a third graph. Look how tiny! Oh no, I didn't want to make it a different size. Now I can't compare them well. Well, poop canoe. Sadness. I'm going to fix it. Roughly there. Okay. So like, it's the tiniest one ever. No, just kidding. It's not ever. 2.765. Okay, what happened? Well, as the level of confidence increase, the t-value got larger, since we needed less area in the tails. I like that. Little short-winded. You could probably say a lot more about this. And tails doesn't have an E, but you get the idea of what's happening. So as I increase my confidence level, I'm going to have less area available here, and since this is centered about 0, my t-value is going to eke out towards the edges of the tails. Now let's see what happens if I change the sample size. Ooh, so my degrees of freedom are going to be different for these too. So I'm going to go ahead and choose Graph and Probability Distribution Plot. What's nice about this one is as I go into Probability View, I'm going to make sure that my shaded area is correct first, since my confidence level is going to be staying the same at 95%. I'm going to set it to both tails and set it to 5% because I want to keep it the same throughout this entire problem. And then I'm going to change my degrees of freedom. Now, remember, since my sample size is 9, my degrees of freedom is 1 less. That's going to be an 8. We're going to hit OK. And there's our graph. So here, our t-value came out as 2.306. If you're concerned that I'm not listing also the negative values, remember, since this is symmetric and you're doing an interval about a single value, both into the left and to the right by adding the margin of error, you're going to end up using the negative one also. It's just that's where the plus or minus is coming in. It's not such a big deal. Yeah, in general, it doesn't matter really. Anyway, so going on, now I'm going to be dealing with n equals 25. So again, graph, probability distribution plot, probability view. I'm going to be making sure that this is correct. I've got a t distribution. My degrees of freedom is no longer 8. My sample size is 25, so I want one less, which is 24. My shaded area, just checking to make sure it stays the same, both tails and 5% because I'm 95. Click OK, and there is my graph. It appears that my t-value for this one is going to be 2.064. Oh, it didn't correct my t that time. Thank you. Word for not sucking. All right, una vez más. We're going to do it again for sample size 101. So graph, where is it? Oh, probability distribution plot, third time's the charm, forgetting stuff. Going to click shaded area, click OK. Here's my t distribution. My degrees of freedom is now 100, not 101. One less, remember. Shaded area, both tails, 5%. Clicky OK. Now, I'm going to show you all these graphs at once in a minute, but I want to get rid of the ones that all have the same 29. No. No. 8. Okay, good. I've got the 3 that I want. Oops, I should record this first, just in case. So my t here for degrees of freedom 100 is 1.895, or 4, sorry. Whee! All right, here's what I want you to look at. I am going to make this bigger so you can look at these graphs together. In a perfect world, I'd be able to line them. I did not mean to do that. I'd be able to line them all up next to each other and you'd be able to say, oh yeah, I see the difference. Now, 8 and 24 look pretty close to each other, don't they? I'm going to line this up from largest to smallest. 8, 24, 101. But I'm hoping you notice that 101, that sucker is thick. Whereas 24 compared to, 8, it looks like these are pretty close, but it looks like 24 is a little bit wider if you're considering the standard deviation. So I'm hoping you notice that, indeed, for different degrees of freedom, the distribution looks different. Yeah, it's got a difference in width about it and other things. This one's got fatter tails than that one. This one looks way more normal than degrees of freedom 8. So what's really happening here, as you increase in sample size, the t-score, or t-value, decreases. And so our confidence interval would be narrower. Oh my god, I'm a bad person. I didn't answer the confidence interval part. Okay. And so our confidence interval would be wider as as confidence level increases. Ta-da! Sorry, I got so distracted by that. As sample size increases. And this makes sense if you think about their position in the confidence interval. N, or sample size, is positioned in the denominator of a standard deviation or sample error. And so as you increase something you divide by, what you get overall as a result will be smaller. And similarly, confidence level is just moving you out further to make you more confident, and so you get wider. All right, that's all for right now. I am done with this recording, and hopefully you understand how to get a t-value a little bit better now.